In this video, we're going to start our Webpack configuration. So what is our goal? Our goal is to be able to compile our client code. Just being able to compile this client.js, importing this client.scss will be a major goal of this video. Now, how do we do it? Well, what we do is we create a Webpack configuration file. So I'm going to right-click down here, create new file. I'm going to create a file called webpack.config.js. Now, generally speaking, webpack.config.js, it expects you to export a configuration object. So you would do something like module.exports equals, and then, config goes here. I'm going to do something a little bit different. I'm going to start off with a function called createConfig, and it's going to take in a value of isDebug. All right. Then what I'm going to do is down here at the bottom, I'm going to say module.exports equals createConfig. Then I'm going to pass in process.env.nodenv does not equal production. Then I'm going to say module.exports.create equals createConfig. So why am I doing like this? Well, the createConfig function is going to return a configuration object, right? But I want to be able to run Webpack from both the command line and from Gulp. And I want to be able to, within Gulp, instantiate a new copy of the configuration, being able to pass in whether or not it's debug. And then in addition, if I were to invoke Webpack from the command line, it will decide whether or not it's in a debug mode depending on the node env environment variable. So this gives us a lot of control. Now the way that we're going to be executing this right now, we will be executing this within Gulp here soon, but right now the way that we're going to do it is by doing node modules.bin.webpack. And when you invoke Webpack, it says output file name not configured. We have to pass in a configuration config.webpack.config.js. There we go. Now, it's not going to do anything because we have not returned any options yet, but it will. So that's how we're going to be executing Webpack. So I'll leave that up there on the side. So for our configuration, all right, this is going to be fun, or not, probably not. Let's go ahead and get started. Okay, first of all, we can't use import statements because this is not going to be compiled by Babel. So we need to import some stuff. First, we're going to import path. Then we're going to import Lodash. Then we're going to import Webpack. Then we're going to import the extract text plugin, which is extract-text-webpack-plugin. So these are things that we need to import. Next up at the top, I'm going to say const vendor equals array, and I'm going to pass in Lodash. So what this vendor array is going to represent are the packages I want to be optimistically pre-compiled, pre-rendered into a vendor.js file independent of the other files. So that Lodash isn't repeated anywhere, it's just in this one index or one vendor.js file. And this vendor array will grow over time. We're going to be including React, React DOM, RSJX, and all the other stuff that doesn't change very often. So for createConfig, we're going to start off by choosing our dev tool. So I'm going to say const dev tool equals isDebug ? Cheap module source map, otherwise null. What is the dev tool? The dev tool in Webpack is the device, the part of Webpack that decides whether or not, or how source maps are created. So we're doing a cheap module source map, And there's many different ways to do source mapping. We could use eval, for example, which is the fastest way, but eval source maps, while very, very quick, don't work with debugging very well. After playing around with all the different source map options, I found cheap module source map to be appropriate for a project of this size as far as performance goes, and also allows us to do proper debugging, line-by-line debugging with a debugger, such as the Chrome debugger or the debugger in Visual Studio Code. Next up, we need our plugins. So I'm going to say const plugins equals array, and we're going to have a new webpack.optimize.commons chunk plugin with vendor as the first argument and vendor.js as the second. So the commons chunk plugin is what's responsible for extracting these extracting vendor components, extracting libraries like jQuery or Lodash or whatever from the main bundle and putting it into another bundle, and consolidating all of our dependencies into a second vendor.js file. So that's what that does. Next up, we need a new webpack.define plugin. Now, the define plugin is fantastic. The define plugin allows us to actually define JavaScript variables in the resulting bundle that will be global variables that we can access however we want. So the first thing I'm going to do is say process.env, and inside of that, I'm going to say node env is going to equal. Now this is important. Node env is going to equal, and I'm going to open up template strings here, quote, and then end quote. Then inside of those quotes, I will open up a template thingy, and I'm going to say, let's see here. I'm going to go ahead and say process.env.nodenv or development. So what I'm doing here is I'm saying, hey Webpack, I want you to define a global called process.env, which is a JavaScript object that's going to have a property called nodenv, and I want it to be the value of process.env nodenv that we had when we compiled. And if such a property doesn't exist in our environment, then default to development. Now this is fantastic, and one of the reasons why it's fantastic is what'll happen is React is full of these if statements that say, if process.env.nodenv is development, then do this, otherwise do that, and so on. When we define the process.env to be something like production, the minifier will actually detect those if statements. So the if statements will look like if process.env node env equals development, then do debug stuff. Now, this will be in the actual like React source code, right? And what's fantastic about it is when we define the process env as production, not development, it'll be the minifier will realize that this expression is always false. And by realizing it's always false, it'll completely remove the debug code from the production build. So it's a great way to do optimization. And in addition to process env, we're going to do another few things. We're going to say is_production is going to be not is debug, and is development is going to be is debug. Now, before I get any further, so these are Booleans that I'll be able to use in my own code to know whether or not we're in development or production. However, these are globals that don't actually exist anywhere, and we have to tell ESLint about them. So I'm going to go into eslint.rc, and I'm actually going to tell it about these things. So I want to tell it about process. So I'm going to come down here to globals. I'll say process is false. I'm going to tell it about is production. Set that to false. And then is development. Set that to false. So now I can use these constants inside of the code that's compiled by Webpack. And I think that's awesome. All right, now let's do our loaders. Const loaders equals, and we're going to have, let's do our, let's do our JS loader first. So I'm going to tab over a couple times. The JS loader will have a test of a regex, which will be dot, escapes dot, JS X question mark, end. So basically, any file, any asset that's loaded that ends in .js or .jsx will be matched by this loader. And the actual loader itself, I'm going to say loader is Babel, which is going to be the Babel loader. And then I'm going to say exclude node modules, because I don't want anything in node modules that is pulled in, that is required in, to be processed by Babel. That would be not a good thing. Next up, let's go ahead and do our ESLint. Our ESLint will have the same test, JSX ? Money. The loader will be ESLint. Notice that I don't have to do ESLint-loader or Babel-loader, right? The loader is going to be implied. And then, of course, I'm going to exclude node modules again. Next up, let's go ahead and do our JSON. So we'll do JSON. That loader will have a test of, not surprisingly, escaped.json money with a loader of JSON. And I'm not going to bother excluding anything for that. Then we'll have our CSS loader for just CSS files. This will have escaped.css money. Actually, I think there's an issue where some of the CSS files don't end. Oh no, that was with WAF. Never mind. We'll do CSS money for this. And the loader. Now the loader for this will be more interesting. It's going to be style bang CSS ? Source map. So what does this mean? This means that first it will be processed by the CSS loader. Then it'll be processed by the style loader. So you can kind of create a pipeline of loaders. And I talk about pipelines of loaders in my Using Modern JavaScript Today course. Then we'll do a SASS loader. Our SASS loader, not surprisingly, will have a test of SCSS and SCSS money. And the loader is going to be style bang CSS ? Source map bang SASS ? Source map. Now these question marks, these query strings, are options that are going to be passed into the respective loaders. And the final loader that we need are the file loaders. So I'm going to say files is going to have a test. Now this is going to be fun. It's going to have a test, which will be a regex. It'll be escaped dot, and then inside of parentheses, I'm going to include PNG, pipe, JPG, pipe, JPGE, or JPEG, pipe, GIF, pipe, WAF, pipe, TTF, pipe, EOT, pipe, SVG, pipe, WAF2, and no pipe. And no, I did not memorize that. These are just going to be happening. These are just happening to be the extensions of the files that we want to load. Things like SVGs and WAF2s, those are things like fonts, right? So we want to be able to match all those. And then the loader here is going to be the URL loader, limit 5000. So what's going to happen here is this loader, the URL loader, if the file is smaller than 5,000 bytes, it'll inline the file. So imagine you have a billion of these really small 64-byte images, like icons or something. Well, what this will do, anything less than 5,000 bytes, will be inlined into the file that the asset's used in, meaning that an additional network request does not have to be made for such a tiny file. And this can significantly improve performance if you haven't been doing anything like this in the past. Okay. So now what I'm going to do is I'm going to say const client entry. You might be wondering why I'm putting all of these as variables instead of putting them straight up into my configuration that I return. You'll see the answer here soon enough. The client entry is going to be Babel, or actually we don't need Babel polyfill. That would be madness. We already have the Babel runtime, so we're not going to worry about that. It's going to be source client.js. And then I'm going to say let public path equals build. Notice that I'm using let for public path because I'm going to redefine it in case of certain conditions. Then I'm going to say if is debug else. I'm going to leave these blank for now. This is where I'm going to modify all of these values depending on if we're in debug mode or if we're not in debug mode. Now with all that done, we can go ahead and return all of these values that we just constructed. So I'm going to return a Webpack bundle with the name of client, the dev tool of dev tool, the entry of app client entry, and vendor being vendor. Remember, me just putting vendor here is equivalent to me doing vendor:vendor. That's the entry. For the output, I'm going to do path is path.join dir name. Remember, dir name is the current directory, the absolute directory that we're in. Public build. So it's going to put it in the public folder into a subfolder called build when we perform a build. Next up, I'm going to say file name is going to be template name.js. The public path will simply be public path. And that's going to be it for our output. Now for our resolve, we need to say extensions are going to equal empty extension .js.jsx. Now JSX is a extension that's sometimes used when we use JSX code instead of a JS file. However, the way I'm configuring things, JSX is going to be valid everywhere in our application. Then I'm going to create an alias. So I'm going to say alias. And the shared alias is going to be path.join dir name source server shared. So anything in the server shared folder will be accessible from the client under the alias of shared. And we'll see an example of that here soon. Then I'm going to say module, and I'm going to say loaders is going to be equal to lodash dot values loader. So what it's going to do is the module loaders are going to be all of these objects sent in as an array. That's what the dot values does in Lodash. It extracts all the values of an object, all the properties of an object, and returns it as an array. And then after that, we're going to do plugins. We're just going to pass in our plugins. Then that's it for now. Let's go ahead and test this. So I'll scroll through this one more time. So just scrolling. And there's a couple other things that we're going to do here in an upcoming video. Then obviously we have to fill this part out in an upcoming video. But I just want to make sure that it works first. So let's go ahead and run Webpack. Oh, I seriously messed something up. Hold on, terminate batch job. Let's try running Webpack harder. And check it out. We got an app.js and a vendor.js. And if we come here to public, there's now a folder called build. And build has an app.js, which, look at that. Our HTML should be, or our thing should be somewhere. Our CSS should be somewhere, at least. Like if I look for body, there's our CSS right there. And we have vendor.js, and vendor.js contains Lodash, which I added Lodash to the vendor bundle. So we are properly building. So make sure that you can get to at this point where you can successfully build a thing. Words. You know what I mean. Anyway, in the next video, we will be taking a look at filling this part out. And then in a subsequent video, we'll talk about hot loading and hot React loading and all that fun stuff, and how we can use the Webpack dev server, and finally how we can integrate it in with Gulp. And with that, we will see you guys in the next video.